So, what is the data communication? Data communication is nothing but this is you have. I think you people have discussed about this 5 layers of architecture and 7 layers of architecture. So, these 5 layers of architecture related to TCP/IP communication, and these 7 layers of architecture will come under this OSI layer. So, before going to that, we'll just understand what about this communication. So the main objective of this communication networking is to enable seamless exchange of data between any 2 points in the world. So where we can take place this exchange mainly takes place over a computer network. And what about this data and information? How we'll represent the data? The data refers to the facts that are collected, while information refers to process the data. So for example, when a result of a particular test is declared, what happens? It contains the data of all the students. Suppose if we want to find the marks who have scored, who have the information, we can know how we can know whether it is passed or failed. Everything that will comes under this data and information. The word data refers to any information which is presented in a form that is agreed and accepted. So, what is data normally? How data is represented? The data can be represented in the form of text, numbers, image, audio, and video. So, normally, how the data is transmitted from one system to another system. So one system we can consider as a sender, another system we can consider as a receiver. And the sender and the receiver, but what is the mode of transmission? Either it is a wired or wireless medium, and what type of data should be transmitted, and how the data will be transmitted from one end to another end. So between that, you can see first this message, how this message is transmitted or communicated. So as I said, the message can be either a text, a number, a pictures, audio, or video. And what the sender will do, the sender simply sends the data message, that is video camera. What is that device? That may be your video camera, your computer, or your telephone, or your workstation, etc. What about that receiver? The receiver that receives the message, okay, same as your TV, your computer, your workstation, your handset, etc. So this is the difference between the sender and the receiver. And what will be your medium? The transmission medium is nothing but the physical path which is connected between the sender and the receiver. So actually here, first we'll see about this wired. If it is wired, what are all the why we are using this for a transmission medium? First, we'll consider this twisted pair wire. Then we'll go for a coaxial cable, fiber optic cable. So these are all comes under wired medium. Normally, when it comes to wireless, we can simply specify the radio waves. And we know that who is the sender, who is the receiver, and what is the transmission medium. The transmission medium is either wired or wireless, and what type of data should be sent, either it is text, number, picture, audio, or video, everything we know. But what happened? So we know everything, so we can simply send the message from one end to another end? No. So actually there is a protocol. This protocol will set the rules and regulations, okay, that is governed by that is governed by the government. We can call this as a set of rules that govern data communication between communicating devices. So how this protocol will be structured? So you will have a syntax, semantics, and timing. So without a protocol, what we can do? We cannot connect any two devices. So with the help of protocol only, we can connect two devices. Even though when the sender and receiver, everything is ready to receive the message, but without protocol, we cannot do anything. Okay, so what are the characteristics of data communications? So the characteristics of data communication is nothing but it depends on your jitter, it depends on your accuracy, it depends on your delivery, and depends on your timeline. So the name itself specifies your accuracy, how accuracy your data will be transmitted, and what is the delivery percentage, and what is the timeline, at what, for example, if you want to transmit a more number of data in a less time, okay, that will define the characteristics of data. And your final is your delay. And here the data transfer mode, which is classified into three. First is your simplex, your half duplex, and your full duplex. So normally we can call this as modes of communication. So if it is three modes of communication, first is simplex, half duplex, full duplex. So simplex is nothing but as a transmitter is there, a receiver is there, a one mode of communication between the transmitter and receiver. So for an example, that is also unidirectional. You can consider for as an example as a pager. So what happened from the base station? You are sending the message. That message will be read by the receiver who is having that pager phone. But what happened is we cannot reply the same message again to the transmitter. So here the simplex is nothing but only one way of communications from the transmitter to the receiver. The receiver can read the message but cannot reply with that message. That is a single mode. We can call it as simplex. Half duplex is nothing but you have a sender and the receiver. The sender will send the message to the receiver. The receiver can receive the message. Again, from the receiver, we can send the acknowledgement or you can send the reply back to the transmitter. This is two way of communication. We can call it as a bidirectional. But what happens? We cannot send the message simultaneously. That is the main drawback in this half duplex system. That is data that can flows in both the directions, but only in one direction at a time. For example, if you are giving 5 milliseconds, for 5 milliseconds, for each 5 milliseconds, your data will be transmitted from transmitter to the receiver. Then there will be allocated another 5 seconds, 5 milliseconds that will be transmitted from receiver to the transmitter. So this will not happen simultaneously. It will take time. The time is allotted for transmitting and also receiving. And next is your full duplex transmission. And for this half duplex transmission, your example is walkie-talkie. And in real-time applications, you can see that. For example, if a sender is having the walkie-talkie at one end and the receiver is having one walkie-talkie on the other end, what happens once the call is over? The receiver can give a message or the transmitter can give the message over. That message means that my part of communication is over. You can start initiating your communication. So from that transmitter receiver end, they will start communicating. So this kind of communication we can call it as half duplex communication. Next is your full duplex. So full duplex is nothing but the data can flow in both the direction at the same time. It is bidirectional in nature. As usual, the same as half duplex, but one main important thing is this will do simultaneously. Okay. Example for the real time application is your mobile phones and data transfer modes. Okay, so the data transfer modes of transmission is different. Data transfer mode is different. So the now data transfer mode is nothing but how many number of bits is transmitted in a particular time. Okay, so this data transfer modes, which is classified into two, one is serial transmission, another one is parallel transmission. So what is serial transmission? The mode of transmission in which the data are sent serially one after the other over a transmission channel. Right. So you can see in this picture, the sender is there, receiver is there. Okay. The sender will send the data bit by bit. Okay. So these bits will reach as the receiver. Okay. So how the sender will send the data? The sender will send the data bit by bit. The first bit will reach the receiver, then again followed by the second bit, then again followed by third bit, fourth bit, fifth bit, sixth, seven, and eight. So totally, if you are going to transmit one byte, so one byte means 8 bits. Okay, so each and every bits will take time to reach the receiver. So this is only a single line. We can call this communication channel as data bus here. Okay, so the data transmission between two computers, which is using serial ports, and the next is parallel transmission, in which the data bits are sent parallelly at a time. Okay, so parallel means nothing but suppose if you want to send 8 bits of data means we need 8 channels over here. These 8 bits will be transmitted parallelly, that is simultaneously from sender to the receiver. So what will happen? Here you can see in this picture, all these data will be sent at a time by using 8 channel or 8 medium to transmit. So 8 pairs of wires will be wireless. If it is a wireless medium, we need 8 channels to transmit from sender to receiver. Okay, so here one by one started transmitting from zeros, 1, 0, 0. So what happened between the serial and parallel mode of transmission? If it is a serial mode of transmission, your data will be sent bit by bit. Okay, so the main advantage is we can use this for a long distance transmission. Which one? Serial transmission. Okay, and what happened next? Second advantage, the number of wires and the complexity we can see here is very less. Why? Because we need only a single channel to transmit between sender and the receiver. Okay, and it is automatically it is cost effective. Okay. So the main drawback here in the serial transmission is here the data transmission rate is very slow due to a single transmission channel. So here itself you can see you have only one channel to transmit. So if you're having a one channel, okay, so what will happen? You can transfer to a longer distance, but what happens? The transmission rate is very slow. Okay, why? Because if I want to send a number of bytes, one byte means I need 8 time seconds to transmit each and every bit. Correct. So here, what will happen? This will lead to less in transmission rate. And next, when it comes to parallel transmission, you can see center and receiver, and this is very easy to program or implement. And from this diagram, you can see that the data transmission speed is very high. Why? Because you have n transmission channel. Based on the number of inputs, you can see, for example, you have a number of bits is 8. So how many bits we can send transmit simultaneously? We can send 8 bits at a time. Okay. And this is very cost effective. Why? Because we need to construct 8 channels at a time to transmit 8 bits simultaneously. Okay. So what will happen is the main disadvantage here is we need more number of channels. So if it needs more number of channels, here the interference will take place. Okay, so for example, you can see in the first bit, so this bit one is get discarded or it leads to error or it leads to interference means what will happen? This 7 bits will reach the receiver, okay, but this one 8 bit is lost. But in case of this uh, serial transmission, suppose if the fourth bit gets lost, okay, so from that point, fourth bit itself, it will start retransmitting the packets here. So there is a main difference between here serial transmission and parallel transmission. Okay, so mostly where we can use this application, this parallel transmission is we can see that audio conferencing, video conferencing, why? Because more number of bits to be transmitted simultaneously. Okay, so that we can go for a video conferencing for live, right? Okay. So normally the selection of data transmission mode is your transmission rate, the distance that it covers, and the cost and ease of installation, the resistance of environmental conditions. So how to select the data transmission mode? These are all the 4 effective parameters. Okay. And we have discussed about what is protocol. A protocol means that rules both sender and receiver and all intermediate devices need to be followed to communicate effectively. We need to give some rules and regulations. Okay, so how we are going to give this is by using some structure. What is the structure involves here? Syntax, semantics, and timing. Normally, what is syntax is? This syntax interprets the meaning of the bits, how each pattern is interpreted, and what action to be taken based on the interpretation. Okay, so for example, if you have number of bits is 0, 1, 0, 1, 0, 1. Okay, so if you want to mention the preceding bits 0 means, so what this bit mention. Okay, so what this bit defines? So this bit defines as a preamble bits or predefined bits. Okay, so that part will be taken care by semantics, and syntax is nothing but the format, how the format should be there, that should be presented, that is your syntax. And timing is nothing but what data should be sent, how fast this should be sent. So that will define timing. So what are the three elements of protocol? We can see that syntax, semantics, and timing. Okay. So normally, if you ask what is protocol, under that protocol, what are the 3 structures there? Syntax, semantics, and timing. And you have to explain that syntax, what is syntax, what is semantics, and what is timing here. Okay. So there are different types of protocols is used. Okay. So as I said, you have in OSI layer, you have 7 layers, right? So each and every layer will have some protocols. Okay, for example, point-to-point protocol is used, TCP/IP protocol, which is used in TCP/IP, and file transfer protocol, simple mail transfer protocol, HTTP protocol. All these protocol will comes under application layer. So these are all some protocols which is used in different layers. And next, what is the standards? So till now we have seen about protocol, that is set of rules, and what is the difference between protocols and rules, we'll see here. Okay, so what is standard? Here standards are necessary in networking to ensure interconnectivity, interoperability between various networking hardware and software components. Okay, so here without standards, what we will do, we would have priority products creating isolated islands of users which cannot interconnect. So as I said there, every the sender is ready, receiver is ready, everything is ready. But what happens? Without protocol, we cannot communicate with the devices. Same as here, everything is ready. Without the different standards, we cannot specify which products we are going to buy or we are going to do in a process. Okay, so both protocols and standards is needed for maintaining a good communication between intermediate devices and also between the sender and the receiver. Okay, so this standard will be classified into two. One is de facto standard and another one is de jure standard. So what is this de facto standards? These standards that have a traditionally used and made by fact or by convention. Okay, so what is it meaning is based on the previous fact. Okay, for example, if you want to refer some other papers, means you will go to the previous paper and check, okay, how this is implemented. So likewise, this standard de facto standard is based on the previous happenings, previous fact. Okay, so with that fact, it will comes under this de facto. The decision will be taken. But what happens is this is not approved by any government or any organized body. Okay, and due use standard is this is maintained by a law or by regulation or by the government. Okay, so what happened is de facto or de facto standard, we can refer with the previous files or previous happening data or the previous fact data, we can refer and we can give the number. But in case of de jure standards, this is mainly governed by law or regulations. So with that regulation only we can follow. But in case of de facto, there is no such regulations will be there. These are not approved by any other organized body. Okay, so these are the two standards which will be used automatically. Okay, so this standard organization networking field. Okay, so what are all these standards which is used in this network normally in networking field? Okay, so what are the examples? I think you people have heard about ISO, International Standard for Standardization, Organization for Standardization, International Telecommunication Union Standard. So this is normally ITUT, and yes, there are several service providers is there, right? Your Geo, Port, Airtel, Vodafone, everything. This all will comes under this ITUT, that is International Telecommunication Union, Telecommunication Standards, right? So if you want to increase the tariff or if you want to decrease the tariff, means they have to get the permission from this ITUT, then they can do this. Okay. So American National Standard Institute, Institute of Electrical and Electronics Engineers, that is IEEE, and Electronics Industries Association. So normally this will relates to your ITUT and also your IEEE. Okay, so these are most widely used and we are most familiar in that. Okay, so then next topic is your layered architecture. This we'll see in the next session.